Welcome you all. Today we are discussing the topic chase memory. Chase memory is a small high-speed type of volatile computer memory that provides high-speed data access to a process and the storage frequently used computer programs, application and data. It helps improve the overall speed and performance of computer system by reducing the latency between the processor and the main memory. That we represent here, chase memory is a small high-speed RAM buffer located between CPU and the main memory. Commonly, chase memory known all the people. The purpose of chase memory is to boost up the speed of RAM. Chase memory holds a copy of instruction, say instruction chase or data, operand or data chase, currently being used by the CPU. The main purpose of the chase is to accelerate your computer while keeping the price of computer low. This would be the placement of chase memory in main memory, in between main memory and that CPU. The figure represents that the placement of chase memory. Here the hit ratio is an important aspect. The ratio of the total number of hits divided by the total number of CPU access to your memory. That is called the hits plus misses is called the hit ratio. So total number of hits divided by number of hits plus number of miss. So example, if a system consisting 512 into 12 chases and 32k into 12 of main memory, the arrangement of main memory and the chase memory is looking like that. There should be three types of chase mapping. One is direct mapping and associate mapping, and then set associate mapping. Direct mapping technique is simple and inexpensive in implementation. When the CPU wants to access data from memory, it places the address, the index field of the CPU address to user to access address. The tag field CPU address is compared with the associated tag in the word read from the chase. If the tag bits of the CPU address is matched with the tag bit of chase, then the hit and the record data word is read from the chase. If there is no match, then there is miss. So we already seen that matching and hit as miss. So this deals about that. So direct mapping directly mapped through this tag. This diagram is betterly explained that it consists in 6 bits of tag and 9 bits of index. Through this we have a comparison with the tag value. So if it is successfully matched with the address, it directly mapping from main memory to chase memory. So more elaborately, this diagram shows that clearly we have an address and consider data value. Simultaneously, it's matched with a tag value here. So through this tag value, we directly map into the data between main memory and the chase memory. Second method is an associate mapping. An associate mapping used on associate memory. The memory is being associated using its content. Each of its chase memory will accommodate the address, main memory, and the content of the address from the main memory. That's why the memory is called content addressable memory, CAM. It allows each block of main memory to be stored in the chase. So the figure representing the associate memory. So the memory content are associated with its address and data. So the associate memory assigned directly to the CPU through this, it have a field of address and data. From that, it associately direct mapping in the sense we can directly mapping the address position to chase memory. Here we using address data like that in between. Set associate mapping, easy control of direct mapping chase and the more flexible mapping of fully accessible chase. In set associate mapping, each chase location can have memory then one pair of tag plus data item. So when compared to direct mapping and set associate mapping, the tag plus one item there in the associate mapping. So in direct mapping we are all done with the tag. Here we also included some more item with the tag. This is more than one pair tag and the data are residing at the same location of chase memory. If one chase location is holding two pair of tag plus data item, this is called the two-way set associate mapping. So two-way associate mapping, one set we seen in the previous slide. two-way set associative mapping, that is one chase location holding two pair of tag and data items. Here it holds two pair of tag and data item. Like that way we have to mapping this chase memory in a three-way. So some replacement algorithm for a chase memory. The replacement algorithm, once we have to fill the chase, which means we are actually locating the content from main memory for to boost up the speed of a process. That's a actual working principle of chase memory. So once at a time, what will be happen? The chase memory get full. So we automatically need to flush the chase memory. For to erasing the content of chase memory, for to making space to store some more new item, we using such a type of algorithm. So that is LRU and FIFO and least frequently used like that. Of course, random method also an algorithm we used in the chase memory to flush the existing data for to creating a space for new data. I hope that this introduction will help you. Thank you.